the shaking is not over. We'll get hit again, and it's going to be a bigger monster.
I've been through a wall.
Oh my God.
The Earth will literally crack open, and you will feel it on the East Coast.
I love you, Dad.
I cannot emphasize this enough. You need to get out, and I mean now. If you can't, God be with you.
All right, hold on. We gotta get over it before crust.
If you're ever caught out in an earthquake, the rock would be the best friend you could ever have. Anyway, we've got a problem. We could use telescopes and satellites to explore the furthest corners of that universe. But when it comes to the Earth, we struggle to know what's beneath our feet. However, if we were to cut through the centre of the Earth, we reckon it would look something like this. There are three main layers to the structure of the Earth, just like there's three main layers to a mango. We've got the tough outside skin called the crust, then we've got the soft fleshy inside called the mantle, and then a solid core in the middle. So how do we know all this? One way could be to study the rocks all around us. No, not that type of rock. We're talking about the rocks that come from volcanoes.
No matter their shape or size, all volcanoes emit gas and molten rock. The journey of these emissions begins deep underground in the Earth's core. The core, which can burn as hot as the surface of the sun, transfers its heat to the surrounding rocky mantle. In doing so, the heat melts some of the rock. This molten rock, or magma, is lighter than the surrounding solid rock layer, so it rises through the mantle. The magma then escapes through vents in the Earth's crust, causing volcanic eruptions.
Okay, well that could work. Studying the rocks that came up from the centre of the Earth could give us clues as to what lies beneath our feet. But it's more a case of piecing together evidence from different sources to get the bigger picture. Now this brings us back to earthquakes and a branch of science called seismology. Now seismology is the study of tremors and shock waves as they move from the epicenter of the earthquake throughout the Earth. In 1929, Danish seismologist Inge Lehmann was examining seismic waves. At the time, the scientists knew that the Earth had some solid and some liquid layers, but thought the core was molten. If that was true, then waves from an earthquake should spread out smoothly from its epicenter. But Lehmann noticed that some of the vibrations seemed to bounce back towards the surface. The only explanation, she figured, is that they must be reflecting off something big and solid at the centre of the Earth. Later studies showed that while some tremors from an earthquake were felt around the side of the Earth as predicted, like on the green lines on the left, tremors from large earthquakes were felt on the other side of the Earth in places they did not expect, like the blue lines. This bending of shock waves can only be explained by the presence of a less dense liquid outer core. So, now to summarise.
From our perspective, Earth's mountains and trenches are mighty indeed, but when you look at the Earth in cross-section, you can see how tiny they actually are. The part we stand on is the crust, which is about 50 kilometers thick, though it can vary between 5 and 70 kilometers. By the way, the deepest hole ever drilled by man is 12.262 kilometers deep. After the crust comes the mantle. It's a silicate rocky shell and about 2,900 kilometers thick. The mantle consists of the upper mantle and the lower mantle. The upper mantle has different regions too. Its upper part, which is viscous and carries the crust, is called the lithosphere. After that, there comes the asthenosphere which consists of less mobile, mostly solid material. The lower mantle reaches deep down to the outer core of Earth. Earth's outer core is a liquid layer of iron and nickel about 2,266 kilometers thick. Temperatures vary from 4,000 degrees Celsius to 5,700 degrees Celsius. And in the center is the inner core. It's mostly solid, a ball made of an iron-nickel alloy with a radius of about 1,200 kilometers, 70% the size of the Moon and about the temperature of the surface of the Sun. It is slowly growing at an estimated rate of about 1 millimeter per year.
Thank you so much for watching, and I hope you learned something new about the structure of the Earth. I learned something new. You should probably leave a mango to soften up a bit before eating it. Anyway, thank you so much for watching, and as always, stay safe.